Hello students, I'll solve some other questions from this exercise and see the question. If x and y are connected parametrically by the equations without eliminating the parameters, find dy by dx, where x equal to a into cos theta plus theta sin theta and y is equal to a into sin theta minus theta cos theta. And given is x equal to a into cos theta plus theta sin theta, y is equal to a into sin theta minus theta cos theta. And let us differentiate x with respect to theta. We will have d by d theta of a into cos theta plus theta sin theta. A is constant and you can take outside the derivative. A into d by d theta of cos theta plus theta sin theta. That is a into d by d theta of cos theta plus d by d theta of theta sin theta. That is a into d by d theta of cos theta is minus sin theta plus, here you can apply the product rule, derivative of theta into sin theta, that is plus first function theta into d by d theta of sin theta plus sin theta into d by d theta of theta, that is dx by d theta is equal to a into minus sin theta plus theta into cos theta plus sin theta into 1, and here sin theta gets cancelled, and dx by d theta is equal to a theta cos theta. Similarly, we can find dy by d theta. Dy by d theta is equal to d by d theta of a into sin theta minus theta cos theta. And a is constant, d by d theta of sin theta minus theta cos theta. That is a into d by d theta of sin theta minus d by d theta of theta cos theta. That is a into d by d theta of sin theta is cos theta minus, here you have to apply the product rule, theta into d by d theta of cos theta plus cos theta into d by d theta of theta. That is dy by d theta is equal to a into cos theta minus theta into minus sin theta plus cos theta. That is dy by d theta is equal to a into cos theta plus theta sin theta minus cos theta. Here cos theta gets cancelled, and dy by d theta is equal to a theta sin theta. And now you can use the formula to find dy by dx. Dy by dx is equal to dy by d theta divided by dx by d theta. Dy by d theta is a theta sin theta. Dx by d theta is a theta cos theta. A theta gets cancelled, and dy by dx is equal to tan theta. And let us take one more question of the same type. If x and y are connected parametrically by the equations without eliminating the parameter, find dy by dx. X is equal to a into cos t plus log tan t by 2 and y is equal to a sin t. And given is x is equal to a into cos t plus log tan t by 2 and y is equal to a sin t. And dx by dt is equal to dy by dt of a into cos t plus log tan t by 2. Here a is constant, you can take outside the derivative, a into d by dt of cos t plus log tan t by 2. And that is a into d by dt of cos t, d by dt of cos t is minus sin t plus d by dt of log tan t by 2. And that is dx by dt is equal to a into minus sin t plus d by dt of log tan t by 2. Here you have to take tan t by 2 is equal to u, log u, derivative of log u is 1 by u, that is 1 by tan t by 2 into d by dt of tan t by 2, sec square t by 2 into 1 by 2, derivative of t by 2, that's equal to 1 by 2. And you have to apply the chain rule to find the derivative of log tan t by 2. That is dx by dt is equal to a into minus sin t plus 1 by tan t by 2 is cot t by 2, that's equal to cos t by 2 divided by sin t by 2 into 1 by cos square t by 2 into 1 by 2. Here cos t by 2 gets cancelled, and that is dx by dt is equal to a into minus sin t plus 1 by 2 sin t by 2 cos t by 2, and 2 sin t by 2 cos t by 2 is sin t, and dx by dt is equal to a into minus sin t plus 1 by sin t, and you can take LCM. Dx by dt is equal to a into minus sin square t plus 1 divided by sin t. That is dx by dt is equal to a into 1 minus sin square t is cos square t divided by sin t. And now you can find dy by dt. Here y is a sin t. Dy by dt is equal to d by dt of a sin t. That's equal to a into derivative of sin t is cos t. And dy by dx is equal to dy by dt divided by dx by dt. Dy by dt is a cos t. Dx by dt is a cos square t divided by sin t. Here a gets cancelled and cos t gets cancelled, and dy by dx is equal to sin t by cos t, that's equal to tan t. Let us take one more question. If x and y are connected parametrically by the equation without eliminating the parameter, find dy by dx. X equal to sin cube t divided by root cos 2t and y is equal to cos cube t divided by root cos 2t. And given x equal to sin cube t divided by root of cos 2t and y is equal to cos cube t divided by root of cos 2t. Dx by dt is equal to d by dt of sin cube t divided by root of cos 2t. Here you have to apply the quotient rule, derivative of u by v formula you have to apply, and that is v, that is root cos 2t into d by dt of sin cube t minus sin cube t into d by dt of root cos 2t divided by root cos 2t whole square, v square, that is cos 2t, and dx by dt is equal to root cos 2t into d by dt of sin cube t. Derivative of sin cube t is 3 sin square t into d by dt of sin t, that is cos t, minus sin cube t into d by dt of root cos 2t. Derivative of root u is 1 by 2 root u, that is 1 by 2 root cos 2t into derivative of cos 2t divided by cos 2t, and that is dx by dt is equal to root cos 2t into 3 sin square t cos t minus sin cube t into 1 by 2 root cos 2t as it is. Derivative of cos 2t is minus sin 2t into 2. Now 2 gets cancelled, and if you take the LCM, it will become like this. Root of cos 2t is LCM for the numerator. Cos 2t into 3 sin square t into cos t. Cos 2t into 3 sin square t into cos t minus plus sin cube t into sin 2t divided by root cos 2t is multiplied by cos 2t. You will have cos 2t into root of cos 2t. This is dx by dt. Similarly, we have to find dy by dt. Dy by dt is equal to dy by dt of cos cube t divided by root of cos 2t. So dy by dt is equal to root cos 2t into d by dt of cos cube t minus cos cube t into d by dt of root cos 2t. That is dy by dt is equal to root cos 2t into d by dt of cos cube t is 3 cos square t into d by dt of cos t is minus sin t minus cos cube t into derivative of root cos 2t is 1 by 2 root cos 2t into d by dt of cos 2t divided by cos 2t as it is. That is dy by dt is equal to root cos 2t into 3 cos square t minus sin t minus cos cube t into 1 by 2 root cos 2t into derivative of cos 2t is minus sin 2t into 2. Here 2 gets cancelled, and root of cos 2t is LCM for the numerator, and root of cos 2t into root of cos 2t is cos 2t into 3 cos cube t into minus sin t minus plus cos cube t into sin 2t. And in next step, we can find dy by dx, that's equal to dy by dt divided by dx by dt, that's equal to cos 2t into 3 cos square t into minus sin t plus cos cube t into sin 2t divided by cos 2t into root cos 2t divided by cos 2t into 3 sin square t cos t plus sin cube t into sin 2t divided by cos 2t into root cos 2t. Here root cos 2t into cos t, root cos 2t into cos t gets cancelled, If you take sin t cos t common from the numerator, you will have minus cos 2t into 3 cos t plus cos square t into 2 cos t, because sin 2t is 2 sin t cos t and sin t cos t is outside. You will have cos square t into 2 cos t. Similarly, you can take sin t cos t common from the denominator, and if you take sin t cos t common, cos 2t into 3 sin t plus sin square t into 2 sin t, because sin 2t is 2 sin t cos t, and if you take sin t cos t common, sin square t plus 2 sin t will remain, and sin t cos t gets cancelled, and you can express cos 2t in terms of cos, that is 2 cos square t minus 1 dy by dx is equal to minus of 2 cos square t minus 1 into 3 cos t plus cos square t into 2 cos t is 2 cos cube t divided by cos 2t can be expressed in terms of sine, that is 1 minus 2 sin square t into 3 sin t plus 2 sin cube t. If you multiply this, you will have minus 6 cos cube t plus 3 cos t plus 2 cos cube t, that is 3 cos t minus 4 cos cube t, and if you take minus common, minus of 4 cos cube t minus 3 cos t in the denominator, 3 sin t minus 6 sin cube t plus 2 sin cube t is 3 sin t minus 4 sin cube t, and 4 cos cube t minus 3 cos t is cos 3t, 3 sin t minus 4 sin cube t is sin 3t. We will have dy by dx equal to minus of cos 3t divided by sin 3t, that's equal to minus cot 3t. And with this much, I'll conclude this video, and I'll continue with the other problems in the next video. Thank you.